All right, let's jump right into today's explainer. We are unpacking a proposal that represents an absolute game changer in artificial intelligence. Our goal today is to really understand a crucial pivot, the shift from making AI models smarter to making the systems around them smarter. We're talking about moving beyond the monolithic large language model. You know that feeling when you're deep in the weeds on a complex project with an AI, and suddenly it just totally loses the plot? It forgets a constraint you established 10 prompts ago, or it hallucinates some completely made-up fact, leaving you feeling like you're managing a super confident but incredibly forgetful intern? Well, today we're going to look at exactly why that happens, and more importantly, how a completely new architectural blueprint proposes to fix it for good. So why does this happen? It all boils down to our current architecture. Right now, we're basically treating a single language model like a totally stressed out solopreneur who's trying to do absolutely every job in the company. Because the LLM acts as the de facto executive controller, it creates some massive structural limitations. First, you've got repeated context processing. The system is constantly rereading your entire conversation history, even the completely irrelevant parts. Second is context degradation. As the chat gets longer, outdated assumptions and abandoned ideas start polluting the AI's reasoning. And third, there's a huge human productivity cost. When the AI fails, you become the debugging system, interrupting your own workflow for endless correction cycles. Here's how we're going to break this down today. First, we'll look at the monolithic bottleneck, then introduce the Executive Cognitive Kernel. After that, we'll dive into context compilation and specialized computation, and finally wrap up by comparing these architectures head-to-head. Okay, let's dive straight into Section 1, the monolithic AI bottleneck, or why forcing everything through one engine is a major problem. The whole idea here rests on one really simple but powerful principle. Different types of cognitive work should be handled by the system best suited for that specific job. Think about it. Writing a creative story, tracking complex constraints, and verifying strict mathematical rules, those are fundamentally different tasks. We shouldn't be shoving strict logical verification and probabilistic creative writing through the exact same engine. It just doesn't make sense. It's structurally inefficient. Which brings us to Section 2, the Executive Cognitive Kernel. We are relocating executive cognition. So enter the Executive Cognitive Kernel. This fundamentally restructures the metaphorical corporation of the AI. You can think of this kernel as the new CEO, or the persistent operating system of the entire architecture. And deterministic is the absolutely crucial word here. Unlike a language model that just operates on probabilities and guesses the next word, this kernel operates on strict rules. It maintains the system's state, compiles context, and dispatches work. Its primary job isn't to do the reasoning itself, but to reliably coordinate the tools that do. Imagine the kernel's daily routine. It wakes up, checks its persistent cognitive state, things like your specific goals and preferences, and it does this completely independent of any individual language model. Then, it gathers only the relevant info to compile a precise execution context, dispatches the actual computational heavy lifting out to specialized engines, and finally, strictly integrates those results back into your files. It's a true rule-following manager coordinating the workflow. Moving on to Section 3. Context compilation and state. It is time to stop replaying the transcript. Now, what's really interesting here is how this system completely revolutionizes memory. Right now, AI just replays history. Every single time you send a message, the system sends the entire ever-growing chat transcript back to the model. Typos, dead-end ideas, obsolete data, the whole shebang. It creates this massive, absurd structural overhead. But the executive kernel changes this completely. It doesn't replay conversations, it compiles context. It constructs a minimal, highly focused, temporary execution payload. It's basically generating a quick, temporary memo with exactly what the model needs right now, and then throwing it away when the task is done. So, where is it getting the info for that minimal payload? From a persistent cognitive state. The kernel holds on to structured things. Your preferences, perfectly established facts, active projects, and procedural knowledge. And here's the kicker. The executive kernel owns this state. The language models don't own it, they just consume carefully selected bite-sized pieces of it when the kernel tells them to. This means your data stays secure, structured, and immune to the AI's suddenly forgetting things during a long session. Next up, Section 4, Specialized Computation Engines. Let's look at Tier 2 of the architecture. This split right here perfectly highlights why a system needs totally different engines. On one side, we have neural inference engines, your GPUs running LLMs. They are fantastic for probabilistic tasks like generating language, creative synthesis, and recognizing patterns.
But on the other side, we have symbolic reasoning engines. These run deterministic operations. If you need strict mathematical reasoning, rule-based logic, or verification, you shouldn't ask a neural network to probabilistically guess the answer. You route it to a deterministic engine that executes the math perfectly every single time. And to back up these workers, the system uses shared knowledge infrastructure. Persistent knowledge isn't just trapped inside a computation engine anymore. The kernel dynamically organizes data using whatever format works best for the job. Think of it like a dynamically organizing library, whether that's semantic knowledge graphs, traditional relational databases, or vector indices. The computational engines just plug in, borrow what they need, and execute their tasks. Let's see how this all comes together in practice with execution dispatch. It's a precise 4-step journey. Step 1. You make a request, and the kernel evaluates the task and how confident it is in what you want. If it's confused, it actually stops and asks for clarification before messing with your data. Step 2, it compiles that minimal execution payload. Step 3, it dispatches the task to the right engine, maybe Neural for writing an email or Symbolic for balancing a budget. And Step 4, it takes the returned results and precisely integrates them back into the persistent state. It is incredibly clean and efficient. All right, let's bring it all home in Section 5, comparing architectures. Let's visualize this paradigm shift.
If we trace this evolution, it's pretty wild to see. With a standard monolithic LLM, executive control and logic are entirely probabilistic. Even with the newer agentic systems we see today, we're still mostly relying on neural planners and probabilistic logic, just with a little bit of retrieved data thrown in. But look at the tiered cognitive architecture. It changes the game. Executive control shifts to that deterministic kernel. Memory goes from messy transcripts to structured state. Logic becomes deterministic when it needs to be, and the system state goes from ephemeral to truly persistent. It literally solves the structural limitations by design.
So what does this all mean for us? The big takeaway here is a massive shift in philosophy. We are moving toward building increasingly capable cognitive systems around models, instead of just trying to cram every capability into one massive model to do everything. Language models are definitely not going away. They are incredible at what they do. They are simply stepping down from their role as the operating system, taking their rightful place as highly specialized, powerful tools within a much smarter, structured framework. I want to leave you with this final, provocative thought straight from the proposal. Intelligence emerges not from forcing every cognitive function through a single computational engine, but from coordinating specialized forms of computation. If that's true, the future of AI isn't just about scaling up one giant brain. It's about building a beautifully coordinated orchestra. Will this tiered approach become the definitive standard for cognitive systems? Well, that's an empirical question, but it absolutely redefines how we should be thinking about AI today. Thanks so much for joining me for this explainer. Keep learning, and I'll catch you next time.